So good afternoon, everybody, and welcome to our Masterclass series. And this afternoon, in this Masterclass, we're going to discuss how to reduce energy costs in your manufacturing plant. It's great to see you all here, and thanks very much for joining us. Our panelists this afternoon are Colin Martin, who is our Global Sales Director here at Colin Carbon, and Charles Sanderson, who is the Director of Process Optimization. So before I hand over to the gents, just to point out the little Q&A panel in the bottom of your screen. And if you have any questions during the masterclass, please pop them in there, and we'll have a Q&A session at the end. I'm going to hand over to you, gentlemen, Colin, Charles.
Thank you.
Thank you, Sinead. Good afternoon, everyone, or morning, depending where you are in the world. I'm just going to share my screen here. And click present. And I think, is that all okay from Sinead and Charles' point of view? Perfect. Yep, good to go. Great stuff. So let's kick off. And thanks everyone again for your time. Appreciate, it's not easy, even just setting aside 45 minutes in the calendar. So really do appreciate those that have joined us today, and hopefully you will get, well, I'm sure you will actually get something from this. Energy enlightenment, how to use data to drive energy efficiency. So myself, Colin Martin, Global Sales Director for Colin Carbon, and Charles Sanderson, who's our Director of Process Optimization. We're going to be taking you through our webinar masterclass today. So, we hope to provide basically 10 insights into the continuous improvement landscape, which can be accurately described as a balancing act, as can most of the day-to-day lives of anyone who has the joys of being involved in operating a factory or an industrial site. We hope to offer some of our perspectives on continuous improvement, data, big data, and how this interacts and influences energy, carbon, and a whole host of other factors. We've got some suggestions for things you might want to consider, and we touch on how we would go about sort of helping to work together to address those challenges. So if I hand on to Charles for thought number one.
Yeah, so I thought we'd start maybe just trying to sort of lay the groundwork, define the field, just talk about what continuous improvement really means, and how that meshes with energy efficiency drives. So if you think about continuous improvement on the next slide, continuous improvement means different things to different people. There's often a range of different sins covered by the term. And so it can be energy and carbon sustainability, but it can also mean things around asset utilization, around quality, around the margin or cost to manufacture. There's a range of different areas that continuous improvement touches. And it can be kind of a big beast to try and get your arms around initially. So what we tend to do is start off focusing on the energy. If you flip to the next slide, you can see, energy is fairly closely related to carbon. The data that you've collected there helps you pretty quickly get to yield, not too far from capacity and uptime, maybe a little bit further from some of the quality safety types of issues that you may be worrying about later on. So we'll often start off focusing on energy in order to sort of set that, gain a beachhead, start validating and demonstrating the value in the approach, and then broaden from there as we go forward. If we flip over to the next slide, I think, we can start talking, as well as a range of different aspects to what continuous improvement means. Sort of on one dimension, you've also got a whole series of problems or questions that you might be asking yourself as you're tackling the CI issue. So you may be initially looking at, look, there's a problem with my process, what's gone wrong? Or, what's happening right now and what's likely to happen next? So can I look forward and deal with some of this stuff? You may then start saying, what can I do better? And to do that, you maybe start saying, look, I've got some gaps in my data, or I need to track multiple different things and I need help keeping all this information fresh in my mind. You maybe start looking at maintenance and how do I keep performing at this high level now that I've found these new opportunities? Or you may be looking for bottlenecks, or how do you run your plant differently? So there's a range of different questions. So not only have you got a range of different attributes of a process that you're going to be looking at, from safety all the way through to energy, but you've also got a range of different types of questions or types of challenges that you're going to ask yourself. And so what that leads on to is, there's always more than one way to do these things. On the next slide, we'll talk about thought number 2, I think. Not only have we got those 2 dimensions of the challenges that we're facing, but there's also multiple different tools, there's multiple different ways to try and tackle those different opportunities. So, if you think about some of those, I mean, for example, let's just pick on one of those questions I asked on the previous slide. Next slide would be, how do I maintain performance? And depending on what your personal skill set is, and what you're interested in terms of or what vendors you've got at the table, the answer to that question might be quite different. And there is no single good answer. There is, as I say, more than one way to do it. So some people may focus on developing good standard operating procedures, good checklists to understand, if this happens, then do this, then this, then this. And if it all goes really badly wrong, call this person. Other people may focus on operator training. So you may go speak to a simulation vendor and they'll build you an operating trainer simulator, or they will help your team learn about the process. You maybe will develop an internal training program so that your operators and your junior engineers get good at spotting and identifying and tracking the problems early. You may invest in process control and instrumentation so that rather than having the people handle it, you let your systems handle it. You let your computer hold through feedback control. And if you get really excited and speak to some vendors, you'll start putting in advanced process control, optimizing control, machine learning, or some of those fabulous opportunities. Or you can also look at data and data visualization. So you can set yourself up with alarms and reports and flags of when you're deviating. So this is just one example. This is like one of those sets of questions. There's 4 or 5 different approaches that we've come up with. If we flip back just for a second to the key insight, I mean, I think that the point is that there's differing levels of skill and resource required, differing levels of maintenance to try and tackle these problems. So what you want to do is make sure that you're working with a flexible partner, or that you set up an in-house process where you can really build on your innate skills and culture. And I strongly recommend that you be wary of anybody who says, look, I've got a magic tool, you just need to apply this and it's all going to be fine. Just trust me on this one. I think there's always more than one way to do it. And you probably want to have a multiple type of approach. So the next slide, the other great thing that we find, and we'll touch on this a little bit later on, is once you start doing this sort of work, you can build that single version of the truth. So most aspects of CI rely on the same basic data. So you maybe start off looking at energy, but in order to really understand where you're using energy, you're going to need to understand what mix of SKUs you're making, what your plant throughput is, what quality parameters are happening, so that you can understand how your yields are working out. And of course, all that data is exactly the same information that you need to start using for a debottlenecking study or a quality study or a troubleshooting of a safety incident. So once you start building all that data and putting it together, that can be quite powerful. What we often see, though, is that data is stored in a range of different databases with limited accessibility. And so people spend a lot of time building spreadsheets to try and draw that information together. And then they end up, as they do that, making different assumptions or normalizing the data in a different way or coming up with different metrics. And then it becomes a nightmare of trying to mesh all the different departments' thoughts back together again. So the key insight here is that you want to try and find a tool set that accepts data from multiple sources, that really is very flexible in where it can pull data from. You're looking for something that makes it transparent as to how the data is manipulated within the platform, but also then supports the reports, dashboards, and alerts, and the assumptions that went into making those things, so that you've got all of the information together in one place, a single source, and then finally make sure that you're finding a tool that conforms to what you need, rather than tells you how to do the process. Change management is a big piece of making these projects successful. Next slide. So the final thought, and then I'll let Colin speak for a little bit, is that good continuous improvement is hard. It's a truism to say that a lot of good engineers have fairly limited data science skills, and a lot of really good data scientists have very limited engineering skills. And so what you really need to do is try and find that sweet spot in the middle where you can draw together knowledge from your production teams, from your utility teams, from your quality, with the data scientists to really hit that sweet spot. And as you move forward, make sure that you've got a team that includes not just number junkies, but also subject matter experts who can really understand what's going on inside of your process or what's going on with your broader system.
Colin, do we have a slight technical issue with the presentation?
Yeah, just bear with me 2 seconds. Sorry for that, guys. It should be back on again now.
Perfect.
And so then, yeah, and so make sure that you're drawing that engineering skill and that engineering knowledge together with the ability of the data and the data scientists who are crunching those numbers. That's where we see these things come about best. I think I'll pass it over to you, Colin, for a bit now.
Thanks very much, Charles. So yeah, building on those first two thoughts, is our third sort of thought that we would have is it's a virtuous cycle. It's meant to improve things, make things better, whether you're looking at energy or into the wider topics that the same data sources can provide, but it needs to be executed well. What we find is, there is a theoretical ideal continuous improvement optimization process, and the data in most industrial factories, sectors, sites is broadly similar, and it starts here on the left-hand side of the screen, whether it's SCADA control systems and information systems, laboratory and quality information management systems, meters, it's the utility plants, boilers, compressed air, refrigeration plants, vacuum systems that are servicing the plant, and the logs associated with those equipments and the shift logs, production logs, so on. And then the enterprise management systems, supply chains, and computerized engineering maintenance management systems. All that data is valuable. All can be brought together in one place, a central collation, a single source where all that data can be cleaned, checked, verified, and brought to the user's fingertips. From there, reports are generated. As I say, the same sources of data, in theory, can generate all the reports for all the stakeholders, whether it's on-site, off-site. The cycle continues down into identifying the problems and opportunities, where to do better from that data. And again, whether you're looking at it from an energy point of view, a carbon point of view, or something else, it all stems from the data analysis, identifying the problems and opportunities, and then taking the changes, whether that's relatively cheap, no cost, low cost operational changes like set point changes, some maintenance, things of that ilk, or a bit more involved changes involving capex and equipment replacements and so on, and perhaps interruptions to the process and shutdowns and welding stops and so on and so forth. But they all will have a desired effect. And once they've been implemented, that effect needs to be confirmed. Yes, we've got 5% more throughput. We've got 10% energy reduction. That's brilliant. We get that in the first month. Do we have that maintained for month 3, month 6, month 12, year 2, and so on? And then the cycle comes round and repeats. Now, this is the ideal, and some organizations can achieve that. Often the case, it's a lot more disparate and disjointed because of what we outlined in thoughts 1 and 2. There's various different systems. Sites have acquired different sites. There's no common systems, there's no common engineering standards, and so on. The real world is different, and what we often see is around this. The collation piece doesn't exist. The collection of data is not digital. It's a lot of manual copying and pasting into spreadsheets and so on, and the reports are, again, disparate. Once the consolidated reports come out, the issues with the data collection at the start are then amplified in terms of time scale and quality coming through. And then there's also the challenges within organization actually having resources to analyze and see what steps to be taken. And then even if those resources are in place, taking the operational changes or having CapEx budget and CapEx resources in terms of project managers, design engineers to implement a successful CapEx problem. And often, little chance to take stock of the effect, let alone maintaining it over the short, medium, and long term. So this is how we see a virtuous circle for continuous improvement and optimization on energy, carbon, and other topics. The execution needs to be done well, and that's often what's lacking with organizations for legitimate reasons. Charles, I'll hand back to you.
Sure. So energy, we really think is not an island. So as I said before, once you've got all that data together, you can use many of the same techniques and the same sources of data to apply to the wider organization. If we flip over to the next slide, we can say, as I mentioned before, there's multiple different aspects of what we could be looking at. The next slide, though, what we really want to do is use energy as a beachhead. Get in there with a good, well-defined project. Make sure that you've got a win on the board. And often energy or utilities is a good area to get in there and start with. But once you've got that centralized data, once you've got a consistent set of assumptions for how you're calculating your daily throughput or working out what the uptime on your process is, you can then suddenly start also tackling yield. And one of the great things about yield, we often see yield and water are two of the hidden areas where you with yield, you can save a small fraction of your incoming material. That's usually a big economic impact. But of course, every time you're making more product with the same amount of energy, that's also impacting your sustainability and energy metrics. You can auto-generate standardized reports. So again, once you've pulled all your energy data together into one place, if you want to do your carbon footprint analysis, or if you want to look at your overall water footprint, or if you want to start looking at how do my individual parts of my plant, what are the uptimes on those different parts of the plant, that's all there. And if you can auto-generate those reports, it saves your engineers time from collating all that data, but it also prevents and helps with some of the transcription errors where somebody writing it down on a piece of paper or typing it into an Excel spreadsheet maybe mistypes one of the numbers, and that can throw all your calculations off, but it's buried in the middle of some stuff, and it's difficult to quantify exactly what's going on. Finally, you can help pin down some of those infrequent quality issues or uptime issues. So again, once you've got that reservoir of data, once you've got all the information together, you can start mining it to look for, maybe it only happens once every 6 months, but if you can start tracking and understanding why that issue is happening, that can be quite a powerful tool to help you deal with some of your other operational issues. And I think that's passing it back to you now, Colin. Oh, I guess not. Sorry, I had a couple more slides. The other thing to mention at this point is, as I said earlier on, there's more than one way to do it. So not only are we advocating that you collect the data, you clean it up, and you put it together in a good, solid format, but if you do that, you can also start drawing into that knowledge base the other information that you have about your process. So some of the design data, what your original mass and energy balance was, what your performance of your individual pieces of equipment are, your fan curves, your compressor capabilities. And if you can draw all that together into a good mass and energy balance, you can then use that mass energy balance. You can not only validate it against your process history if you've got that data in the history, but you can also start inferring bits that are missing from the fundamentals of your model. There's a lot of work these days in this concept of hybrid models or artificial intelligence to fill in the gaps. So if you don't understand your mass transfer coefficients inside of a reactor, for example, you can start inferring that from the data that you've got available. So you can not only fill in gaps in your model, you can also start filling in gaps in your process and instrumentation. So if you've got that good consolidated mass energy balance that forces the data to be self-consistent, you can start estimating how much steam you have being used. And then you can also use that fundamental model to start looking at what would happen if I changed my process. Could I increase my capacity? What equipment would I need? What would it cost me to throw a new SKU into my production mix? What would happen if I replace this heat exchanger, or if I replace this boiler with a heat pump? How would that change my system? So, it's a really powerful tool to pull all that data together. So look for a platform that can support that sort of analysis as well.
I think this touches on quite well, Charles, that, I think it was your good self actually that shared, if you have a portfolio of 20 plants, for example, senior manager, and these plants can use their data to increase their output from their fixed assets, what they have on site just now, by 5% each. Times that by 20, that's an entire new plant that the parent organization doesn't need to build. So
right,
there's a huge potential benefit when it's wrapped up with multiple sites.
Yes, absolutely. Maybe the next slide, Colin.
Yeah. So yeah, thanks, Charles. I think I'm picking up here with our fifth thought. All being said on the first four thoughts, everything needs to start by getting organized. Now, this requires quite a bit of integration work or minimal integration work. It just depends. We call it digging out the data, but all those systems we've mentioned, are they already networked? Is there much metering coverage? What's the infrastructure like on a particular site? Does that need to be upgraded? Does there need to be work done on that? But the organization piece generally is where you start. There's other areas you can start off in the flow, but if you want to truly get on top of the data requirements, you need to organize that data and start to integrate those sources, and bring them into a platform where you can start to have one source of truth. Now, getting all the relevant data, I suppose, is a key. There is potentially lots of data, and in this world that we are at the moment, the industrial internet of things, data lakes, industry 4.0, smart factory, a lot of hype, a lot of buzzwords kicking about, a lot of big players kicking about as well. And a lot of people in this space, often they can pick up a SCADA system, pretty straightforward, but many can't pick up integrations with local PLCs, qualities and limb systems, cost and scheduling data, and third-party data providers, for example, your local utility provider, who can provide an access into the utility meter, whether it's incoming electricity or gas or other, or even the local weather station, so you can properly correlate your production throughput and how that impacts on the performance of the plant. And in addition, where, and I can put my Crowley badge on here, where we are very strong is that ability to integrate with all this kind of operational technology, which is very difficult and hard. Many people can do the cloud-to-cloud interfaces here on this side of this diagram, but this operational technology integration is very difficult, and it's something that Crowley excels in. And we can bring those devices all together in their various machine languages to a device on site, whether virtual or physical, harmonize those languages and then securely transfer into the cloud to then take advantage of all those sort of cloud-to-cloud interfaces that are available as well. So that, by getting organized can be a bit scary as well. And we often come across some sites that will have, minimal or no meters. That's okay, because once you get your data or what you have and you don't have any money to put in new sensors or meters, you can start to go from first principles with some of the modeling techniques that Charles has mentioned, and we'll come on to a little bit as well, to develop things like soft sensors and adjust your KPIs that, from a first principles point of view, can give an indication of how the plant's performing, even without an actual physical meter or sensor in place. And an example just of getting organized is the forgotten cooling tower sitting at the back of the plant, good data available on it, I think, from local PLCs. No one really looked at it. There was maybe a technician going around checking it was performing, so on. Once it was connected and into our platform, we were able to look at its load, the capacity, the ambient conditions, and very quickly deduced that the cooling water was not as cool as it could be. Therefore, there was poor condensing, loss of vacuum, and ultimately excessive steam consumption in the whole associated system. By rebalancing, optimizing the controls, and spending a minimal amount of money, a significant steam reduction was achieved, the equivalent of 1 tonne per hour, in the region of 250,000 sterling a year. And that is just from organizing, getting visibility in one place, able to do some quick analytics, and then taking some action. And that's all from just data that was fairly readily available and just needed an integration. So we move on, get yourself organized, brilliant. But thought number 6, data alone is pretty useless. You can almost drown and be too much data. What you actually need is insight. This is where you need to pull it all together. As we mentioned, pull it all together means collecting that information, the relevant data, making sure it's clean, consistent, there's no gaps. There's questions around accuracy of meters and how you maintain and check that. But all addressable. But once you have it in that one place, one point, the reporting can then be generated from there. And if these digital connections, or however far you can go in that first instance, are made, the time saved there from the manual cutting and pasting and drudgery is really useful for a lot of clients, because if you are doing 10 hours a week of spreadsheet cutting and pasting, if that's reduced to 1, you now have 9 hours to focus on this element of the reporting and moving on into the analysis and gaining some insight. Again, as you get into a platform, and this is our example here, that information in place, the reporting being generated, time could be spent to do some initial analysis. And again, a similar system here. The vacuum was improved through an improvement in the cooling water temperature. Steam reduction was commensurate with that improvement in vacuum and the steam valve shutting back. So again, that vacuum-based system, we were able to visualize the data in this form to give you quite a dramatic indication of how that improvement was made. And this again was from, in this instance, our subject matter experts looking and conducting this analysis on the data available to hand. So that's all well and good, but no man is an island. Energy is not an island, but no man is an island. So widening the approach is really, what to do next. So individuals can start to do analysis. It's really good if you can bring other expertise within the site, within the group, or from outside in to sort of help with that analysis, identify the problems and the opportunities. Where can we get better? Where can we improve? And bringing in that expertise, within and without. If you could, bring in a boiler specialist, bring in a refrigeration specialist, bring in a process specialist at any time. Could you bring in people with knowledge of the original equipment manufacturers, guidelines and design and their approach? Imagine if you could have all those expertise to hand right away, as you needed, to help you identify the opportunities. But similarly, could you bring in expertise within your organization, whether on site or at other sites? If you had a platform that allowed you to do that, they could assist in the challenges you're facing on your site and what you were looking to do with some of the problems that were arising. So again, from our platform, we quite value the ability to socialize. So as we run through here, there's an issue in the air compressor house. Here you can access this all in one place. You can check out the key parameters, design information, metadata. But the beauty here is this can then be instantly shared with anyone outside or inside the organization who has access to the system. Therefore, that expertise can be brought in to assist with the analysis, with the suggestions for resolutions, root cause analysis, and improvements that can be made. And say that expertise can be in-house, outside, or a mixture of both. And the one additional feature is it's all in the one place. It's all the same. So any user who comes in would see the exact same set of data, set of analysis, and the ability to comment and annotate on it as well to provide suggestions and guidance. So I think I will hand back to Charles for thought number 8.
Thanks, Colin. So yeah, trying to be a little cheeky here. Take action is great, but really what you want to do is take strategic, directed action. So if we flip to the next slide, what we're talking about now is that bottom corner, that quadrant where you're trying to, I've got a number of different opportunities. How am I going to quantify, develop, and put those together? So if we flip to the next slide, I think, and I noticed there was a question came in. I was looking at that while Colin was talking about what you do if you just don't have any meters, or if you have a limited number of meters. That is a real problem. If you don't have the data, it's really difficult to work through some of the things. Again, I'm a big advocate of trying to pull together as much of the fundamental knowledge that you have, that design information, the performance of individual pieces of equipment into a consolidated computer model, so you can then use that offline tool to help supplement your online learnings. And you can actually start developing soft sensors. You can start inferring what measurements are and doing that. The other thing that it's really helpful, and this is what the slide here is talking about, is that law of unintended consequences. Once you get into a big, complicated, interactive plant, like many food or agro-food processes that we deal with, but a lot of other big industrial processes are as well, you start seeing stuff interacts. So you may have a project where you're saying, hey, it'd be great to recover the condensate. There's a bunch of heat in this condensate. I could use that. That's wonderful. But if you're stealing if that condensate is otherwise going back to the boiler, and by stealing the heat from it, you're just making the boiler work harder, it's probably not a great project. So what you want to do is understand how those things mesh together and how they interact with each other. The other thing that we see time and again is that having the great idea and doing the changes is only part of the problem. What you've got to do is bring the team along with you. So making sure that the operators and the junior engineers, that the people on site are comfortable with what you're doing. If you can actually show them and explain through the maths what's happening and help sort of back that up with historical data saying this is how you operated some of the time, this is how you operated the other time, we're recommending this is the better place and this is why. That can be a really powerful adjunct to having the data and having the analysis to go forward with it. And then finally, as I started on this slide, if what you've got is that big model, you can start linking back to live data and start saying, look, given this ambient temperature or this performance of my cooling tower, then this is what I think the process should be doing. And then you can start comparing that to reality. If you flip to the next slide, I'll go through this one pretty quickly because we're running low on time. But again, this is sort of trying to do that graphical representation where what we're doing is we're pulling all that fundamental design data, we're turning it into detailed process models. We're then using those models to running those models a number of times to generate limited space data sets where we can then do a statistical reduced order model. But then we can take those simple models and put those live and online with the process. And of course, I don't have to go down that complicated modeling route. If I've got enough good data and I do have all the metering that I need, I can go straight into that statistical model analysis and build that into my process. But flipping quick to the next slide is a very quick example on this one. You know, this is a plant where we were able to do that. This is an oilseed plant where there's a lot of interactions between how the cooling tower is working, what the ambient temperature is, how deep of a vacuum you're pulling, how much material you have flowing through the evaporator. And so it's quite difficult to intuitively know how much steam I should be using. What we were able to do was build that large complex model, turn it into a simple reduced order model that we put inside of the software platform. And so then the user can actually see, look, this is where you're actually operating. This is where you think you could be operating. And this is how you close the gap. And you can see on the chart below, once we put that in the hands of the operator, they were able to close that gap up pretty effectively and start saving a significant amount of steam. So this isn't just theory. This is stuff that really works. I'll pass back to you, Colin.
Thanks, Charles. So thought number 9, yeah, low-hanging fruit grows back is starting to become a well-worn anecdote, but you know, as does high-hanging fruit as well. Or alternative, why does the CFO always hate energy efficiency investments? And you know, some feedback we've had from CFOs is if all the energy efficiency investments they've made had actually worked, they would be exporting energy back into the grid and elsewhere. Now, maybe a bit tongue firmly in cheek there, but it sort of gives you the impression of what they think on often. And that was the genesis for us as a company developing this software was behaviors, things happen overnight on continuous 24/7 production operations. The night shift needs to make a manual intervention. Whether they actually set back all the controls back into the optimal, or they're just happy that their shift's over, they've got the plant back up and running at some semblance of steady state, and they're handing on to day shift, who are quite relieved to see the plant is back in some semblance of steady state. They've got production coming through and the quality seems to be okay. Excellent. It's Friday, day shift. I've got the weekend here. I'm going to leave this steady so no one has to get called out. Happy days. Now, that scenario I myself have come across many times before, and where our platform can help is, SCADA systems are great for immediate process alarms, immediate criticalities that need to be addressed to keep the process up, running and going. For your sort of longer term sustainability aspects, making sure you're at optimal settings at all time, something else could be quite useful. Again, in this representation here, we have an example of chillers that don't need to be used at a certain time of year, depending on certain conditions. Now, that's a behavioral change, a cultural change, and some control changes that are required. That takes initial bedding in to actually get that into place. But then there's always a churn in staff and the potential risk, that a manager moves on and people forget why this thing was actually getting done in the first place. This provides a very good snapshot in terms of the kilowatt hour savings, the fiscal element of those savings. And then in order to make sure that that is sustained over the short, medium and long term, this element here of our platform, you can put in certain rules. This one here is if a temperature is going too high over a period of an hour, provided that it is throughput, that is then flagged up. And the functionality and configurability here means it can go to a shift leader within shift. And then if that's not addressed or actioned in an appropriate timescale, it can be cascaded and escalated, if you will, into further management layers within the organization. The benefit of this is it's purely looking at things from an optimization, whether that's energy, carbon, water, yield, or any of the other aspects that we've touched on. It can keep an eye on that. And things do happen on a night shift. If you do need to make the manual intervention, then this will flag up in a relatively timely manner that you're back running. We actually need to optimize your controls again to bring you back into peak plant performance, rather than, if you go back to one of our earlier thoughts with that disjointed continuous improvement optimization flow, you might not find out for 6 weeks that you've been running in a suboptimal condition. So wrapping up, thought number 10, from our observations on a range of industrial sites, even large commercial sites, most utility systems, 55% on average, boilers and associated utility tiny systems are not connected. They're not integrated into a SCADA system or one central network. Steam users, big users of energy, often at least half, not even got a meter on them. Generally because steam meters are quite expensive and they're quite difficult to install as well. 20 to 40% of control loops not tuned correctly, poor 3-term PID control, manual data collection, far so common it's not true still in this day and age. And there's also, no one continues to go to Blockbuster anymore, driving a car to go and get a physical DVD or even worse, a VHS cassette. But in the industrial sphere, still a lot of practices that are 20, 30, 40 years old, but just still accepted. 80% of plants do not have even a site-wide detailed mass and energy balance, and some 90% of plants still use static KPIs instead of fully dynamic, modulating and skew and properly correlated to weather conditions, design of the plant, and the other influencing factors. So depending on the size of your plant or your energy spend on site, anywhere between 100,000 to 500,000 euros per annum potential savings from these sort of themes and topics that all come from gathering data, organizing data, analyzing data, and taking action. So what would a 10x improvement feel like? As I mentioned, no one, unless you've got a particular nostalgia, goes to Blockbuster anymore. I don't even think Blockbuster exists. But it would feel like the joy of getting 3 hours back every day to actually do proper continuous improvement work rather than copy and pasting from spreadsheets. It would have all your required data at your fingertips, automatically cleaned, sorted and correlated. You would be in control, you would have mastery of your own domain, and you would know that you could probably spot problems today and ideally within shift and take steps to address them. Thank you very much everyone for your time. Bang on 40 minutes. I think we've got maybe 5 minutes for some Q&A. I'm going to stop sharing my screen just now and see what questions we actually may or may not have.
Yeah, that was a great one, Colin. It was nice to talk about VHS. Good question here. Did you answer it, Charles? During, I know you were talking about it. What can you do if you have no or very few actual meters on site?
You're on mute, Charles.
We've muted.
Yeah. I'm on mute. I tried to cover it. I mean, I think, yes, if you don't have the data, it's really, really hard to do stuff. But often what we found is that you can infer or fill in a lot of the gaps if what you do is you really try and understand the details, and that's an energy balance of your process. I think the other thing that I didn't mention, but we've also seen is quite useful is as you go through this exercise, as you go through this analysis of starting to say, look, I'm trying to understand this part of my plant better, you start saying, well, I really, really like this specific measurement. And so you can start being smart about how you deploy your capital. As Colin says, it's expensive to put in meters. You want to make sure that when you put in meters, you're putting them in the right place and you're getting the right data. And if you're doing that as part of an exercise where you're trying to really build and use the data live, that's a very useful, it's a very efficient way to spot the opportunities and fill the gaps. Not just, I think it would be good to have one there, but actually, I need one here. This is how I'm going to use it, and this is how I'm going to justify it to my CFO.
Colin, can you help us deliver carbon savings, or does the customer have to do all of the work?
Yeah, that's quite a good question, actually. The answer is, as ever with lots of these, it depends. Some organisations are, speaking from a Crowley point of view, they're quite interested in getting a needs service, and there might be a platform, a reporting mechanism, so on. We offer a range of services around that. So if the customer is stretched for resources, we can provide those. We have subject matter experts that can analyse their own data and set it up very quickly, and even in an offline fashion as well. So the answer, it depends what the customer wants to do. But yeah, we can help do the analysis and actually ultimately go into the hard engineering of delivering carbon and energy and other savings. Or we can also just provide the recommendations for clients to go and do it themselves if they're well resourced, or it's more difficult. Or in this world and COVID, although fingers crossed, touch wood, we're coming out of COVID, where we are restricted in terms of travel, so we can make remote recommendations for the people who are actually allowed on site to go and do. And that's attractive for a lot of clients these days, just because of the general restrictions in life.
I suppose that ties in nicely with the next one, which is my team's already overloaded. Why would I want to take on this extra load? Kind of answered your question, isn't it?
Yeah. Charles is on mute.
I'll take a shot at that to maybe give Colin a break. I mean, as Colin said, yeah, we've got resources that can help. I mean, I think that is actually one of the sort of dirty little secrets of doing a lot of these CI projects. Is it's great to put in the system, it's great to put in the software, but it does take time and effort, and you need people available to do it. And to do it really well, what you want to do is you want to make sure you've got that mix of skills, so that, as I said in one of my slides earlier, you've got people who really can understand and crunch the data, mixing with people who really understand the process and what's going on with the process, mixing with the financial guys who are going to understand, this is why we care about it, this is how we're going to make dollars out of the product at the end of the day. So yeah, we've tried to set Crowley up not only as a software delivery team, but also as a group of engineering services. So we've got people on staff who are experts in boiler systems, refrigeration systems, data crunching, modeling. So you can pair those people. If you've got them internally, that's great. If there's a couple of gaps on your bench, we can help fill that if you need to.
Cool. Colin, can you give an example of value created from something other than energy?
Yes, the project I've been involved in quite a lot recently. It touches in again from the same sources of data. We were able to analyze, and both myself and Charles in previous lives were chemical engineers, process engineers, if you will. So it's all about bringing materials in, doing a process to create a more useful product out, in very simple terms. So within that, you have various control parameters and so on of what you can do. And with a number of our clients, they have certain quality parameters. So you can only have X amount of material A in a certain product. And what we've worked on there in terms of increasing value was touching on yield. That there was more moisture could be in this co-product stream. We worked to install a sort of control system on that is integrated into our platform. So then that could provide visibility again to the operating team who actually are running the plant on a day-to-day basis, and they could optimize that, that component within that particular product stream. And where energy maybe has, for example, €1,000 impact, yield tends to be of a 5x nature. So that would be a €5,000 impact. So there was a energy benefit here by being more controlled on that parameter. There was a commensurate energy reduction, but the 5x benefit of that energy reduction was the improvement in the yield and how they could get more revenue on the market for that said product stream. So yeah, that's one example, and we have many others, but I don't want to drone on or bore people with any more of those, and I'm conscious of time. We have one question there from, I think, an Eamon Ryan mentioned, is the solution software can be site-based and list of current clients active. Well, we can't share a list of our current active clients, although we do have a number of references and testimonials. But from Crowley, our solution software is cloud-based. And we can start on an offline mechanism. If there's certain data being reported on a spreadsheet or a CSV file or some other form like that, we can start up with a trial account offline before we even get to site. But ideally, getting organized is looking at operational technology integrations. So that element would be some site-based activity. It's a lot cheaper than you think these days as well to do those kinds of integrations. And as Charles touched on, we can help work with our clients to prioritize it. CapEx and funds in general are limited. So what do you absolutely need to do to get started? You might have enough to go as well and do some modeling and go down that avenue. But the cloud-based software means any upgrades to UX, UI are all happen seamlessly. We don't have to send a CD to site for it to go into a desktop PC to be upgraded, so on and so forth. So there is a site-based element for that integration in the operational technology, but the actual software is SaaS cloud-based.
So it's almost 10 to. Do you have time for one more question? You're avoiding the European CO2 price. Is that jumping past that question? Do you think the recent increase is going to make companies take notice? Do you think that's, yeah?
I've got some strong opinions on that. I mean, as a company, we've been around for 12 years. We've been, carbon is in our name, and it's associated with energy sustainability. There's perhaps, in the fairest way to put it, there's been some false dawns on this particular topic. Certainly in Europe, that CO2 price has gone, 24 months ago, it was around about 6 to 10 euros a ton. It got up into the mid 20s, and whatever was almost the response by many. This year, though, it's accelerated from mid 30s up into peaking into mid 55s. That at that point is starting to cause people to take notice. The thing around that market is very political. Biden coming in, the potential green Biden wave, the money and the commitments that are being talked about in America, sort of warlike Franklin D. Roosevelt kinds of New Deal levels. If that becomes seriously tangible, and generally the Americans are good at throwing money at stuff, to be fair, if that happens, then you've got the two biggest sort of trading blocks in the world, Europe and America, in tandem, driving a carbon reduction net zero plan, and then everyone else will sort of fall in behind that. So we'll wait and see.
Yeah. Sorry, to be fair, China is not exactly a laggard in this area either. I mean, so
true.
It does seem to be a global phenomenon. I think Europe trading the carbon is probably ahead, but I think if you look at some of the COP commitments and some of the big investments that are going in, it is a pretty global and fairly united front, but particularly with China and the US as well as Europe. I think the big three.
Yeah, the big thing, and I think we would say that this decade ahead will be sort of defining on it.
Okay.
Yeah.
Very, very quick answer to this one. How can you take energy data and use that to understand something like maintenance or safety?
I'll take that one really quick. I mean, I sort of touched on that in the presentation earlier, but I mean, in order to understand maintenance, right, what you're trying to do is to see what equipment is failing, when's it failing, what's leading up to that failure. If you've already gathered a big body of data where you're understanding flows and temperatures and pressures and compositions, that really can help you get a lot of data, not all of the data, but it's a good solid body of the data available for maintenance. And it's the same issue with safety. If you're trying to look at what happened leading up to this incident, you're going to want to have a lot of that process information available to you. And then what you can do in both those cases is if you can get that data together and consolidated, you can work out what happened last time. You can then start putting the sort of watchers that Colin was talking about in place. So you can say, hey, watch out, you're starting to get close to the edge. This pressure is rising and this temperature is rising. Last time that happens, bad things happen. So maybe you want to take action now.
Sounds good. So thanks very much, guys. That was really, really good, really interesting. And thank you, everybody, for joining us. And we'll see you again at the next masterclass. Thank you.
Thank you. If there's questions, please feel free to ping Colin.
Yes.
I'll do my best to answer. Thanks, everyone. Take care.
Goodbye all.